Hello, this is Ben Goertzel, and I was pleased when my good friend Mingyu asked me to share a few thoughts today on the first day of the year 2022 about transhumanism, AGI, longevity, nanotechnology, and associated technologies. You know, Mingyu and I have known each other for some time, and the basic elements of our conversations haven't really changed over these years. I think, along with many others in the global transhumanist community, we've been excited about the potential that advanced technology has to, you know, both create new forms of life and intelligence and matter far beyond human comprehension, and also to help solve the problems that plague humanity in everyday life, like, you know, scarcity of resources. We still have hunger on the planet today, and you know, mental illness, warfare. I mean, I think advanced technology has the potential both to lead us onward to currently incomprehensible new frontiers, and to fix so much of what ails us today. I've seen this since the early 1970s when I was a small child. Mingyu is younger than me, but I believe has also understood this, you know, since his own childhood. We're not the only ones to see this vision, this potential that by using science and technology to manipulate matter, whether in the form of biotech, nanotech, or computer programs, we should be able to, you know, do amazing things going far beyond most people's imaginations. The realization in practice of these visions, of course, is another thing. So what I want to talk about a bit today is, you know, where do we stand now at the beginning of 2022? Where do we stand now in terms of bringing the grand visions of transhumanism into reality? And you know, that's a very big story, because the use of technology to transcend the current human condition and to better the current human condition. I mean, this is something that cuts across all walks of human life, right? But I'm going to focus substantially on AI, because that's the core of the work that I do. But AI also gives you a view into pretty much every other aspect of advanced technology, in that you know, there's pretty much no technological pursuit that can't benefit from a greater level of intelligence, and because of that, AI is being applied all over the place. So where are we now in 2022? You know, in some ways, in the AI field, we've achieved an incredible amount. In other ways, you know, we're still back where we started. I mean, we have computer programs that can do tremendous things now. You know, just as computer algebra has been taken for granted since the 1970s and 80s, now face recognition is taken for granted. People don't even think of it as AI. They just think of it as you know, a routine technological tool. Natural language processing, we now take it for granted. A machine can put together sentences and paragraphs that read much like they were written by a human, although they don't always make as much sense as what humans produce. You know, humans don't always make that much sense either, right? Now, On the other hand, while we have AI tools that can do a lot of exciting and a lot of practical things, from face recognition to language processing to, say, trading stocks on Wall Street, helping diagnose what's wrong with a car, helping carry things around a factory, we're still, in some ways, we're still close to ground zero in terms of practical realization of general intelligence, what I've called AGI, artificial general intelligence. We don't yet have machines that can create, imagine, dream, and invent in the manner of human beings. We don't yet have machines that know who, what, and why we are, or why they are, even to the extent that people do. And it's a very interesting position. I think that we're basically toward the end and near the beginning of the first of three AI revolutions. There's a narrow AI revolution of AIs that can do some very specific things quite well, be it play chess, play Go, figure out why your car engine is breaking, or write a news article, recognize a face, create a deep fake. The next AI revolution will be the AGI revolution, AIs that can generalize and invent and create new things going beyond their training or their history. The third AI revolution, ASI, artificial superintelligence, going far beyond what we humans can even imagine. And narrow AI has advanced so far now. It's just a routine technology, but by this point isn't even considered amazing by most people. When your social media network can recognize your face, or when a news article summarizing the weather or sports is produced by an algorithm instead of a human, we just consider that routine. And we're even frustrating when things like, full self-driving take a few years longer to realize than had been envisioned. So we're at a stage where a bunch of technological capabilities that at one point would have seemed incredibly advanced and amazing now seem quite routine. And I think we're near the transition between the narrow AI revolution and the AGI revolution. And to think about concretely how this may go down, think about the way computer vision advanced. In 2014, we had some systems called AlexNet that for the first time were able to recognize faces reasonably accurately. Then between 2014 and 2017, we had some incredible advance in computer vision, where computer vision went from being a sort of research technology to being the center of a commercial industry. And between 2018 and today, we've seen natural language processing over a few years go through a similar arc of progress, where NLP was a research topic in 2017. There were some commercial systems, but now all of a sudden natural language generation and moderately advanced, although non-AGI natural language understanding, now this is a routine tool of the trade and industry, and there's loads of startups leveraging it, right? So what we see there is a timescale of a few years for an AI technology area to go from research to widespread commercial realization. And why does it take a few years? I think that's because of how long it takes people to read each other's papers and send emails and look at the results of their software code running and modify the code a bit. The progress in these computer technology areas is still carried out by human beings who are interacting according to their good old human bodies, albeit serving largely as nodes in a global brain. My hypothesis will be that we're going to see a similar, say, roughly 3 years arc of incredibly rapid progress in AGI, in artificial general intelligence. And, I'm supposing that this will start sometime in the next, say, 3 to 5 years. I mean, I could be wrong. It could be 10 or 15 years. I really don't think it's 50 or 100 years. But I think we're going to see a few years arc of extremely rapid development in AGI, just as we have in computer vision and in NLP, where AGI goes from being a sort of obscure research area to being, something that works really well, not yet perfectly, but works well enough that it's being focused on by companies, large and small, every university, every government agency figuring out how to leverage it. So that's where I think we are now at the dawn of 2022. We're not too far off from the transition between the neuro AI revolution and the AGI revolution. There's going to be a few years of extremely rapid progress in AGI technology. Now, I'm hoping to seed that, of course, with my own team's work on AGI. I'm now heavily engaged with building a new version of the OpenCog AGI toolkit called OpenCog Hyperon, which we're hoping will enable us to massively scale up the OpenCog algorithms we've been working on for so long. I mean, just as, the core ideas underlying deep neural nets, convolutional neural nets, and the main engines of the current neural net revolution, the basic ideas there were nothing new. What was new was GPU technology and associated software that allowed these same old algorithms to be experimented with at much, much greater scale. In the same way, we're hoping that OpenCog Hyperon, running on modern computer chips and then on, custom graph processing chips like a graph core and a Cerebras and so forth. OpenCog Hyperon running on modern chip architectures should allow the AGI architectures and algorithms we've been working on in OpenCog to accelerate and then to do far more than they've been able to do in the past, just as GPUs and associated software did for deep neural nets. So Hyperon is an OpenCog version that's intended to support using modern chip technology to massively scale up some of the AGI algorithms we've been working on in the OpenCog project for some time, which include neural networks, but they also include symbolic logical reasoning, probabilistic programming, evolutionary learning. In OpenCog, we've been putting together a variety of different algorithms and a common distributed knowledge metagraph called the atom space. We've had some quite interesting prototype results there, and we're hoping that the Hyperon upgrade of the OpenCog technology will allow us to massively scale up OpenCog, and then this can trigger the breakthrough to general intelligence, the launch of the AGI revolution. SingularityNet, the blockchain project of which I'm CEO now, is oriented toward the infrastructure underlying AI systems like OpenCog Hyperon, but not only OpenCog Hyperon. And what we're looking at with SingularityNet is, how do you make it so that once you've made the breakthrough to AGI, once you have that AGI system there, that it can, colonize the globe, but in a beneficial and decentralized and democratic way. I want AGI to roll out more like Linux or the internet than like a proprietary system. So there's pieces of the AGI, everywhere on the planet, owned and controlled by different people, and they're all cooperating together with the intelligence emerging from the overall network. Hyperon is one hypothesis regarding what cognitive algorithms may underlie this. Singularity net is the infrastructure that should allow the decentralized, self-organizing, participatory aspect of the infrastructure underlying AGI. So, yeah, you can find out about this stuff at singularitynet.io or by Googling OpenCog Hyperon. There's pages on the OpenCog wiki. So it may be my own projects of Hyperon and SingularityNet are going to be the ones that allow us to break through to the next phase of the AI revolution that will allow us to transition from the narrow AI revolution to the AGI revolution. But if it's not my own projects, you know, the good news is there's a bunch of other people out there working on AGI from their own perspectives, and we're very likely to see a dramatic breakthrough happen, you know, within our lifetimes, potentially within the next, say, three to 7 years. I mean, putting a precise timeline on these things is always hard. It depends on all sorts of exogenous factors. It depends on how much funding goes into AGI projects. It depends on things like, you know, global pandemics and global supply chain issues in computer parts. I mean, we can't pin these things down to an exact date, but we can see where we are in the technological development process. And so I've focused here on AI, on the breakthrough from narrow functionality to the ability to really dream, understand, cognize, reason in a way that people do with deep self-understanding and semantic and pragmatic understanding. But what's exciting, of course, is you could tell a similar story with regard to every other area of technology development relative to transhumanism. I mean, you could tell the same story with regard to human longevity research. We understand so many pieces of what makes humans live a long time. We're integrating all this data together into knowledge bases. We're running machine learning algorithms on related longevity data, and it seems we're at a point where we have huge amounts of data and huge amounts of understanding of subsystems now, and we need an integrated systems biology approach to pull them all together. I mean, in nanotechnology, you know, we're able to do more and more and more with DNA origami and also spiral ligamers, all sorts of related engineered molecular systems, sort of at the boundary between biology and engineering. And again, you just need one breakthrough to be able to scale all this up. Brain computer interfacing. I mean, Elon Musk and Neuralink get a lot of press, but actually there's a dozen exciting BCI, brain computer interfacing projects around the world. And you know, right now it's largely about assisting the disabled with controlling sensory and motoric prosthetics, but the basic understanding that's being built in terms of interfacing between computer systems and brain systems, I mean, this is gonna allow us to jack ourselves into the same decentralized AI networks that OpenCog Hyperon and other AGI systems are running on. And you know, these, compared to when I started my professional career in the late 80s, let alone when I started reading and thinking about these things in the early 1970s, you know, these things are just so close at hand right now. It's almost incredible. I mean, there's a saying among parents of small children that, you know, the days are long, but the years are short. And I think the same thing applies to advanced technology development. I mean, it's amazing what we're doing decade by decade. It's incredible where we are compared to when I started my career. Year on year, it still sometimes seems like painstaking that, you know, why when the ideas behind something like OpenCog have been clear for so many years now, why does it take year on year on year on year to scale it up. You know, when Human Genome Project was around the turn of this century, it's 22 years later. Why is it taking so many years to like mine the implications of the human genome for curing human disease and prolonging human life? It can seem like a bit of a slog when you're in the middle of the research, or when you're just, watching your family members become sick and get ill and even die, and waiting for the therapies to come about. It can seem like a long slog, but of course on the historical time scale, we're into the singularity, and these technologies are unfolding incredibly fast compared to at any time in human history. Bearing in mind, throughout most of human history, I mean, the whole world, technology and nature would remain about the same through each human being's life, right? Which is completely not the case now. We're seeing radical change within our own lifetimes. And getting back to the theme at the beginning of this talk, transhumanism, all these technologies, AGI and narrow AI, nanotechnology, biotechnology, brain-computer interfacing, and quantum computing, a host of other things I haven't had time to mention. I mean, these are all coming together. We're at a point where these are all poised to make further dramatic transitions of progress. And, there's multiple aspects of what this means. These technologies will allow us to solve material scarcity and solve mental illness and bring people closer together and help people uplift their consciousness. These technologies will also allow us to create new forms of life and mind, going beyond what we can imagine now. And the challenge we have now is to both create these amazing new technologies and to roll them out in ways that are for broad benefit of sentient beings, including all human beings on the planet today, and animals and other plants, other living forms on Earth today, and also new forms of life that we haven't created yet. And this is really what transhumanism is about. It's not going beyond humans in the sense that humans are gone and something new takes their place. It's going beyond a narrow focus on our current conception of humanity and embracing what humans are now, embracing all sentient life forms, and embracing new forms of human and human-seeded life forms that we haven't yet created. And what's cool is that we're living at a time when this is not only a wild science fictional dream, but it's a palpable, reasonably near-term consequence of actual technical work that we're doing, and which is happening around the globe. I mean, here in America, in China, in Africa, in Russia, in South America, everywhere on the planet, there are brilliant, inspired people working to realize these goals, just like Mingyu and myself. So, yeah, I think I'll leave it at that for now. But I look forward to speaking at the next one of Mingyu's gatherings, face to face. Once technology has fully crushed this pandemic and travel returns to usual. Bye bye.
知识星球人类增强进化岛致力于提升人类增强系统认知，希望可以帮助到更多人缩小与金字塔尖人群对未来预判的认知差距。欢迎有识之士加入，一切都还来得及，但机会永远只留给有准备的人。